Okay, I forget to do a recording, but I think it'll be okay. Okay, so we have all this selection, projection, and product, and different union and different. So we normally use this during our SQL learning Oracle. When we type all these commands, it's more toward all this. Okay. Yes, what you want to say? Oh, haven't decided. Okay, so all this performance is to retrieve the data from the database, and of course, if we want to make our result much more what we call filter fit to our requirement, we will use this join, intersection, and division. And of course, just now we already mentioned, we won't be able to put everything in one table. So a lot of time we want to be normalized. So we put all the table based on the object, the most simple behavior. So in a different table. So, but all these tables, they actually have a relationship between each other. So that's why we have to use this join, intersection, and maybe division. So we have one sample, and this sample we'll use towards this chapter. Okay, so we have a branch staff property for rain, and the private owner, client, and viewing. So all this is individual table, but it is actually related. And based on our chapter, the slide, we'll go through one by one. Okay, so we have this branch and a branch number, where is it, and now the address, or like the postcode. For staff, where you work. Okay, where you work, based on the branch number, we know where is the staff work, and all the detail, okay, that is necessary. Okay, so this one should be okay, but we have a listing salary, which is a little bit different from others. Then I'll continue. We have sorry. Okay, then we have this property for rent. Okay, so this one is something they want to rent it out, and this is some client. Based on the client that they do the record, which client is actually viewing the property for rent, and when is the viewing, and what is the comment. Okay, so this one is something individual. For current business, we always try to do this. If we have the ability to do the recording of the customer response, then of course we will keep track. And if there is too many comments, say this one is not that good, then maybe we will exclude from our property here. So we don't waste our time because that is too bad. No one will actually stay in this part. So we can do the decision of exclude from our property from rent. Okay, so this one is based on the customer response or the comment. Okay, then we continue to this part. Okay, so we will go through all these relational algebra operations here. So again, if you already left at school for a long time and you almost forget all these mathematics parts, then it is time for you to do some revision. Okay, although it is not 100%, but at least we have the basic idea of what is all this selection, projection, and product, union, intersection, and different. What is all this about? Okay, so if you still after this class you still are not really understand, maybe you need to go back and find whether you have any book, or even you can go YouTube and search for all this relational algebra operations. Okay, so we will go not only go through the part, but we also have all this the natural join, semi join, left or right outer join, and we also have a division and some of the example of a division. Okay, so we'll go through one by one and see whether you whether you're familiar with this, still familiar with this. Okay, so the first one we just now already mentioned, we have this selection. We always in order to show the result, we always have to select all from the table. Okay, so we thought by thought. This one is what we call selection. Okay, so work on a single relation, one table, and define the relation that contain only those tuplets or row. We have this tuplets here, but normally I will try to call it row. So this one is individual row, and I want to select that row that specify a condition. So it match the condition, then only I want it to show up. Okay, so we'll display all the attributes. So this one will display all the attributes for that row, and this is what we call selection. Okay, so we have every of this may have an example, and I may ask you to give some more example in order to impress your thinking. Okay, so we have an example here, selection. We list all the stuff with a salary greater than 10,000 pounds. Okay, so we have this salary which is 30,000 pounds, 12,000 pounds, 18,000 pounds, but this one only 9,000 pounds. Okay, so the query say want to list out all salaries that exceed 10,000 pounds. Okay, so this one is based on only one table stuff, and the result come out here should be all the things. Okay, you can see all the things, but it's based on the record or the row is already filtered. For those that less than 10,000, let's say Mary and Julia, is actually excluded from the result here. Okay, so this one is selection. Okay, so I repeat again, this one is single relation. And you go through all these row or tuplets, and you need to satisfy the condition. Only those that are greater than 10,000 pounds will display in the result here. Okay, it's Jiangqing here, Hong Jiangqing. Hong Jiangqing. No. Li Huirong. Okay, Huirong, we have one example here. List all the stuff with a salary greater than 10,000 pounds. Can you give another example? selection. You can write query. If you're familiar with a query, you can write any query that display the result of selection. Hui I think you need to correct your answer a bit. For branch number, normally if you see a ABC, then you won't be able to do a comparison of a greater than or less than. Maybe. No. Okay, this one is my concern. Normally, I'll be on for this greater than or less than. Normally, this one is based on numeric. It means, let's say, number or let's say salary. So if you want to use a branch number, then maybe you need to change this comparison. Now, very wrong. No idea. Okay. Okay, so yeah, this one is my concern. For if you see some of this, let's say branch number, product ID, we normally if the number here actually start from a character or wacha, normally the type, the data type will be wacha. Okay, so it's hardly you can use it to compare greater than or less than. This one is my thinking. Different this SQL, database SQL may have a different treatment to this type. See how to compare one number, one character to another character. Okay, so this type, if you want to do comparison, normally we use it equal. Normally we wouldn't say it's greater than or less than. If you want to do a comparison, maybe this DOB will be better. Okay, so say branch number, use a branch number, select everything, and a branch number equal to or greater than this B005. Okay, so this one is array. Our using this selection is actually a select everything, but only those record that match the criteria will be displayed. Okay, then we continue to the next part. Comparison of this projection, selection, and projection. Okay, so this projection it works on a single relation, same thing compared to based on this selection. It is still only one relation, one R, and it defines a relation that contains a vertical subset of R. So vertical subset of R, you can see we have this column here. Okay, column. This one is row, right? And this part is column. And it extract the value of a specified attribute. So in the keyword here, we have this specify attribute and eliminate all those are duplicate. So if it's duplicate, then just ignore the one to show. And I can see here only specify those field that want to show to the user. Okay, so project yield value for selected attribute. Only the selected attribute will be displayed. Okay, so you can see from here we only want to show what? We only want to show staff number, first name, last name, and the salary. So you can see for this part we have a staff number, first name, last name, and the salary. Okay, so we only want to show this. This is what we call projection. Okay. So okay, so after we select, you can see only a specific field is lit up, but it's all record. Okay, it's all record. Okay, so we have a question here. Kaiman, we have a question here. The question already gives us the SQL statement, and it asks us to write one related relational algebra. This is the only question that related to this relational algebra in this chapter. So we can refer back to something like this. Okay, this one is something that you need to show. Okay, so you can see here, but we have this where theory is less than 1000. So how are you going to write the relational algebra? Okay, so adding another theory less than 1000. Okay, thank you. The answer combined with all this. So combined with all this, then the last part only I add in a theory less than 1000. Okay, then we continue to the union. Okay, so we already go through a selection and a projection. Let's see what this union means. Okay, union of a two relation of R and X. So previously we only have a one R, okay, one table, and this part we say we have a two table here. We have a two relation R and X, and they define over this for R and S contain all the triplets of R or S or both for R and S. So the duplicate part being eliminated. So the R and S must be union or compatible. So we have an example later. So this union of this two table actually it have a one attribute that must be same. Okay, one attribute must be the same. Then it can just use it to combine these two tables together. Okay, so if R and S have I and J triplets respectively, these are I and J, it must be union compatible. It's often by concatenate them into one relation, so they can just combine, and the maximum of this will be the number of this I plus J triplets. So let's say R have a 10 record and S have a 10 record, then the maximum of this union should be maximum is equal to 20 record. Okay, so this one is for the union part. We just if a picture will be better to describe, then you can see we have a R and we also have a S. You know, for this the union is actually all this. Okay, all this. But of course, those that record that is already a duplicate, then you will only use one. Okay, so union. The company A has bought another company B. So this one is an example. Prepare, we will answer example again. And so we can see we have a company has a two customer table. So company A has a customer table A, company B will have a customer table B. And what we need to do is once they merge together, then all these tables should merge as well, right? Okay. So merging the customer table with a customer two table, then we use this union. So the customer record will merge together. Okay, so this one is one example. Okay, we have another example here. List all the city where there is either a branch office or a property for rent. Okay, so actually we just want to show all the city. We want to show all the city. So for our record here, for branch, we want to show all the city here. Then some of the properties that we use it for rental, we have another table. So we want to combine all these cities together, then we can use the union. Okay, so the code that the result that show out will be all of this plus all of this, but eliminate those that is a duplicate. So only acid one. So you can see Glasgow, we have a lot of Glasgow here, but only show this one. You won't have a duplicate item in this union. Okay, so this one is the SQL that will display this union. Select city from branch, then select city from the property for rent. Okay, then you put a union, and it will show one result. Okay, so Wei Biao, Li Wei Biao. Li Wei Biao. Wei Biao, we already have two examples for the union. Can you give one more? Okay. Wei Biao, I'll just use another method. We already have a city, but Wei Biao wants to show more detail. We use this the street as an example. Okay, thank you, Wei Biao. Okay, so city only give us 4. You can see we still have some city, this street. Normally won't be seen. We seldom have place, but it seems like we still have a possibility. Okay, thank you. Okay, so this one is union. Okay, so this set difference sometimes I say sometimes it's seldom used, but you just see what is the meaning of this. So it lists all. We define a relation consisting of tuples that are in a relation R. Okay, we say the record is in a relation R, but not in relation X. So only those record that show in R but not in X will be written. Okay, show set the difference. If the record appear in both table, then of course it will not show. Okay, so you can see here for R we have this record. For X we have the same record here. So this record they don't want to show. Okay, so only I show those record that is not exist in X. Okay, so R and S must be union or compatible. So we can see this from a union onward, we can see this is union or compatible many times. The attribute must be quite similar. So let's say city. Just now we also have this street. Okay, so we also have this branch number. Okay, so we have an example here. List all the city where there is a branch office but no property for ring. So this one, we have an example here. So we have a branch in all these cities, but there's no property for ring here. So which one? London. Okay, only this one. We have a branch, but there is no property for ring. Okay, so this one is destroyed. Okay, so the result here, it show out we have a branch here, but actually there's no business. So this one is finding something that the branch actually are doing nothing to find the property for ring. But of course, maybe there is the requirement or the possibility of this is quite high that all the property is already rent out. Okay, so this one is trying to find something that is maybe it's too bad or maybe it's too good. Okay, so this one is set the difference. So we use it to find the extreme case. Okay, so the SQL for this part is list all the city where there is a branch office but no property. So we say select city from branch, and but we say accept. Okay, we accept. Those are cities that show in a property or foreign. So the only one that will come out here is this group. Okay, so this one is a slight difference. Hong Kong. Hong Kong, can you give another example? Different. But the result here, it won't show anything, or it will, I should say, it will show everything. Not, you can use another example, not need to follow this table actually. It's okay. Okay, we serve this. If you can find any, then just type in this chat room. Okay, we go to the second part. Next part. We have this intersection. Okay, so just now we want to set the difference. We want to previously we have a union, and now we want to have this intersection. Okay, previous one are the different. We will only show those records that exist in R but not in X. But this intersection, want to mention, we want to find something that union. Again, this one is a union or compatible, and you want to show those tuplet that exist in both R and S. Okay, so this one we just draw two circle. Only at the center part of this is the intersection. Okay, so this one I think easy. Okay, so the management I want to know which customer are dealing with both companies. So just now we have one case. The company A take over company B, so they merge together. Their customer record also want to merge together, and now they find out this thing. They want to find out which customer is actually doing business with both companies. So if doing a business with both companies, then they treat it as not loyal. Okay, not loyalty. So they use this intersect. Actually, this one is not quite good example. Not for business, yes, but for us to trace this is not very good. Use the intersect to combine both of this row from a 2 array. Then I return only those rows that appear in both sets. So find customer A and customer customer A, customer in a company A, customer in a company B, and they just combine. Check which one is actually exist in both of this table. Okay, so this one is using an intersect. Okay, we have another example here. List all the city where there is both a branch office and at least one property for it. List all the city. We have London. We have Glasgow. Okay, so this part we want to list out all the branch, and those cities that have at least one property for rent here. So this one have everything. You have London, have Glasgow, have and only a bistro didn't have. Okay, so the result come out is only these three cities. So this one is again ignore. Okay, so you can see the difference here when we have this accept. So is the valid or the reverse our answer for this. Okay, so these are all the city where there is both a branch office and a property, so they intersect these two tables and see which one actually have both branch and also have some at least one property following. Okay, 28. 28, can you give one example? Intersect. Using postcode. Okay, just show again. Okay, using a postcode. Yes, possible. Okay, 28 answer is using a postcode. We can see not only our city can use it, but also this postcode also can use it. But you can see from here, we have this Aberdeen city. The postcode is AB2 and 55U, but for this one is AB7 and 55U. It seems like a little bit different. Okay, maybe the printing is not so good, but we can just see this. All those is one city, but the postcode sometimes is different. Okay, so we can use this to state whether this property for rent is the same place of our branch. Okay, so not only a city, but also use postcode. Quite logical. Even let's say we say in Ipoh, we have a different postcode. We have a 30100, 31350, and all others. Let's say some in Percham, some in Ipoh Garden, maybe some in this station 18. The postcode is all different, but we still say we are from an Ipoh. Okay, so this one is something that we can use the postcode to differentiate. Okay, can. Okay, we have a 5-minute break, but before you go, please put +1. Then we have a rest here. Okay, thank you. Okay, let's continue. Okay, so we already go through five different relational algebra. We have a projection, selection. This two is only a single relation. We only select, and based on the criteria, we try to simplify or eliminate some of the data that is not really needed. Then continue, we have this union, intersection, and difference. So set difference, we have one criteria here. Previously, for projection and selection, we only have a single relation. But for union, intersection, and difference, we have this criteria mentioned that it needs to be union or compatible. Okay, so this union or compatible means the two relations, it needs to have some fields, one field that can match together. Okay, so we say compatible. It means some of the field or some of the record may exist, some may not exist. Okay, so but let's say city, both table must have this city field, and in order they can do some matching or find something that is not the same, and try to show it out. Okay, so this one is the purpose or the usage of using union, intersection, and difference. So based on this coding SQL, we can find out something that is able for the management to make a decision, or they can try to make some changes. Okay, so let's say just now they want to find something that let's say the customer exists in both companies, then they can treat it as not loyal. Okay, so then they can just give more discount to those that exist only one company, and they can try to check again, let's see whether those are customers that sit in two companies, maybe they want to eliminate, or of course, if the business is good enough, then they can need to entertain this. Okay, so this one is something for business, they can do such kind of decision based on a different kind of SQL, they can find out something. Okay, another one is, let's say just now we mentioned some of the city, we have a branch, but there is no property for rent. Then what for? We have this branch there, so no business. Then the management may need to make a decision whether this branch, the office, whether still need to be there or not. Okay, so of course, for long term, of course, it's always needed, but for short term, they can make a decision to cut some employee. Okay, so this one will help them help the management to do some decision. Okay, so after the point, we come to this thing called joint operation. Okay, so still the same. We have three kinds here: natural, left outer joint, right outer joint. Okay, the last one here we have a semi joint. We'll go through one by one. It's quite similar, but the result will somehow totally different. Okay, so for natural joint, we can see we have an example here. We have a relation R, relation S, and R we have a AD. But for S we have a BC. And based on this relation, which one have a relationship? So we have this A. We have this A equal to 1, and this one is 1. B have a 1, and C have a X and Y. So this one is actually related to this part. So if we want to build another table based on the relation, we can just use it A1X, A1X, A1Y. Okay, so A1Y. So combine over this, we use this natural joint. We can have another table for this part. Of course, this one is based on the relation. So the result of this natural joint is a set of all combinations. Okay, all combinations. So we have based on different combination here. So this one is the first one, and this one is the second one. So we have a different combination, or all the combinations we will just show in the last natural joint. Okay, so equal on the common attribute name. So this one is the common attribute name. Okay. Okay, then we have an example here. This is the client number, name, and a comment of all clients who have a view of property for ring. Okay, so this one we already mentioned. For business, if they keep checking of this viewing, this one is actually the activity of a business for this property for ring. Every of the client goes to visit this property, then person in charge will always ask what's the comment. If they accept, of course it's good, then they can make a business. But if they didn't accept, then they may ask for comment. Okay, maybe it's too small, or some of the facility is actually not there, then they will not accept this. So you can see maybe it's too far. Okay, so this one is some result come up. So based on this, they can make another table. And of course, when they are having this meeting or discussion, maybe they want to do some changes. Okay, so this one is the use of a natural join. They join two relations together, and of course, based on the different criteria. So previously we mentioned this view the property, and at the same time have this comment, then they want to show it up. Okay, so we only show these three record. Sometimes it's good and not. Okay, but the answer here is show everything. Not only those that have a comment, but anything that is no comment will also show up here. Okay, so this one is using a natural join. Okay, so this is the first kind of joining. We continue to the outer join, and we see what is the difference between this natural, left outer, right outer. Okay, so to display a row in the result that do not have a matching value. Okay, so do not have a matching value. This one is the keyword. In the join column using outer join. Okay, so we have this left and right. You can see for left, this part is open. For right, this part is open. So the symbol is different. So during test or exam, pay attention to this part. Others I think should be okay, except this one is a little bit different. Okay, so you can see here for left outer join, we have a R and a S here. Left outer join. Okay, so we have this table R and S, and you can see A here have B1. Here B1 have a CS and CY. But for this B, we only have a B2 here, but there's no B2 here. There's no B2 here. But the result come out here, we still have a B2, and there's no C here. Okay, so for left outer join, it means it do not have a matching value in a common column. So in short, anything that is shown in R, we want to show it out. We not really bother whether S have this value of B2 or not. So if no, then I'll just let it. Okay, so this one is for left outer join. For right outer join, it's just terbalik. Right outer join, it's just a terbalik. Later we will just go through a left outer join again. But for this right outer join, it's the relationship just totally different. So if we have this, just now we have R and S here. Okay, so you can see we have this S. This one is for the relation S, and this one is for the relation R. And you can see we have this production child here, but any of this employee exists here for production, but there's no production here. That's why the record for this name and employee is actually empty. Okay, so the difference between the left and right is based on the majority or the attention for this type. For left, the attention is only for employee. For the right, the attention is in the department. Okay, so you can see the difference between this part. Then we come back to this part. Okay, so we have an example here again. Left outer join, the important part or the attention part is in the employee. We have all this, and we just want to relate this department to the second relation. So let's say we have R and S here. So finance, but there's no finance here. For sales, yes. For no. For sales, yes. Executive. Okay, so you can see from here we have when we have this left outer join, we want to show everything of this employee table, whether they have any of assisting a manager or not. We don't care. So that's why you can see for finance, we didn't see any managers here. For executive, we also didn't see any of these managers here. So because for the department of finance and executive, there's no manager in charge. Okay, so that's why you can see for left outer join, we not really worry too much about this manager, whether it's there or not, but we just want to show the result of all the employees, see whether got any, see whether they belong to which department and who is their manager. Okay. Okay, so we have some other examples. Produce a status report on the property of the wing. Okay, so for property viewing here, this is a property for ring. We only have 1, 2, 3 that have a matching, right? In PG4. Yeah. Okay, so we only have these are 3 property number that have a viewing, and the result come up. Okay, so we want to show this left outer join, see all the property for ring, whether there is any of this viewing or not, but the majority are still in the property for ring. Okay, so you can see we list out all this is based on all the records of individual, all here. Whether you have any of this viewing, we don't care. If you have more, then we just continue, continue. So you can see we have a client CR56 here, this is PA14, CR62 here. Okay, so you can see every of these, they link to the property number and list out all the client number that viewing on this property, and of course the view date and the comment. For some of this property that didn't have any viewing, actually I don't care. So the result is all not here. Okay, so you can see the main point is still listing all, but at the same time they want to know the viewing of the client and the comment. Okay, if it is no, then I just put not here. Okay, then we have this query, select DO, PO, then from branch 1, left join, property for ring. Okay, so the question here lists all the branch and the property. The city is linked together. Of course, if there is no such thing, say the branch, all the branch, you mentioned some of the branch actually didn't have any property for ring. So there is no mesh branches here. So it is okay. So that's why we have this branch B, left outer join. The main point is in the branch 1B. So if there is no any property for ring, it is okay. So they will just show everything of a branch 1. And if there is any of a property for ring, then they will just show up. Okay, so they use this city to join 2 tables together. Okay, so the result still will come out will be something like this. For those city, for those property for ring that does not, for those city that does not have a property for ring, then actually the result come out will be something like that. Okay, so this one we already mentioned. for left outer joint and right outer joint, the result is just terbalik or reverse. So the right outer joint relation R and S. So now the concentration is in S here. Okay. So the result of a right outer joint is set of the all combination, still the same thing of R and S that are equal on their common attribute name. So for previous one, this one the common attribute name is city. In addition to the tuples in S, they have no matching tuples in A. So you can see we have this important point here, say tuples in S. We want to show everything. If there is no matching in R, it's okay. Okay, so we have an example here. We have this. We want to show everything of this S department. If there is nothing in nothing, let's say production in S, is okay. We just want to show. Don't worry. Okay, so if for this part, we have this department production and we have a manager Charles, but there is no employee work under this manager. It's okay. Okay, so this one leader without subordinate. Okay, we have another example here. List branches and property in same city and any of these are matched. Branch. Trinket. Okay, Trinket, this one is the table. We have a branch, we have a property for ring here. And you can see we have this left joint. So the branch left joint property. And we also have another one, branch right joint property. Okay, so can you, based on the table here, discover what is the different result between left joint and right joint? Okay, Trinket is theoretically answer, but my question is, what is the different result between these two? Want to try? The SQL code is quite similar. Only the right joint and the left joint is different. Okay, we didn't have it's okay. Thank you, thank you. For left and right, the record come out will be somehow different. Okay, so based on this, for left, you can see this distro here won't have any result. So for this part, it will be empty for left for outer joint. But for right outer joint, it will show all the record here. And this part will have only one result. But for London, it will have two results. Okay, linking up to this one and this one. Okay, so the record come out will somehow also different. Okay, so we finish this part and now continue to semi-joint. Okay, so we already have nature left, right. Then I come on to this last part here, we have a semi-joint. Define a relation that contains the tubules of R that is participate in the joint of RS. So we have a 1 here. We also have a 1 here. Okay, so based on these two, of course, it will be X and Y, right? But for this semi-joint, when we join together, we only have this part. So because B is not any, there's no relationship with this X, so you just ignore. For 3, there's no relationship with R, so you also ignore as well. Okay, so based on this relationship, we just show an example here. So this is the complete detail of all stuff. So it means we will have the record of all this. But now, if want to eliminate some of the record, and say only I want to show Glasgow. Okay, so only those that Glasgow will be shown. But for the table of this stuff, there actually no such field called city Glasgow. Okay, so we need to link back to branch, and based on the branch number, based on the city name Glasgow, to determine whether this record need to be shown. Okay, so we will need to get the ID of Glasgow B003. Then only we can go through the searching of this stuff, which stuff is B003. So this one, and this one. Okay, so the query for this part will go through something like this. Okay, it will go through this part first. Select from branch B, branch. And you want to know the branch number equal to this, and that the city is actually equal to Glasgow. Okay, so it will show the branch B, and based on this branch B, it do the linking of a stuff with the branch number. Okay, so it finish this part first. We know the branch number, then only we go through the list of stuff, checking this stuff, showing all this stuff that is branch number equal to B003. Okay, so this one is the semi-join between this stuff and the branch. Because there is no actually a relationship of stuff with city, but we have to join it using this branch number. But the criteria is actually city. Okay, so this one is what we call a semi-join. It's not really a correct join, not a correct, very tight join between these two tables. Okay, then the last one here we have a division, and this division is like filter. I try to call the word filter. Based on this tuplet X, we try to do the filter from R. Those that is not within this X criteria will be just ignored. That's why we have this A. You can see A have 1 and 2. B also have 1 and 2, but C only have 1. So for R, we want to have A and B only. Okay, so it is like filter, but the criteria is actually more than this, whether it's equal to 1 or equal to 2 or less than more than. But its criteria is anything that is acid in this triplet X. Okay, so that's why the result come out when R division by S, the result is A and B. So we have one example here of this division. We try to identify those students who already complete database 1 and 2. So 1 and 2 is the is in the tuplet X. We have two criteria here. One is the database 1 and one is the database 2. And when we want to find this division, we need to go through and check whether this is finish 1, database 2 or not. If yes, okay, so this one is the one success record. Then I'll continue to check others. Although straight have also a finish or compiler 1, maybe some others, we don't care, but we want to check whether the criteria is here. Okay, so we continue to do the checking. Eugene, only 1, and there's no database 2, so Eugene is no. Okay, the last one here we have a Shara, database 1 and 2, so Shara is good and can be added to is the result of this division of R and S. Okay, so this one is one example of this division. To the definition of a cell using a filter. So filter and the criteria is based on the relation of X, and will be easy to understand. Okay, so we have another example of this division, and the criteria here is PG4 and PG36. Okay, so based on these two, what is the result? PC? Yes. What do you think? What's the result for this one? Okay, PC answer is CR56 and CR62. Let's see. Okay, so for the table here, we have PA14. Okay, so the property number of PA14 is not in fact here. So this one, no. Okay, so we have a PG4. Okay, PG4. We have a one note here. Checking. Okay, we have this one is PG4. Okay, checking. 62 have a PA14. There's no PA14 here, so this one wrong. The last one here we have a PG36. Okay, so this one is PG36. So we can check back again. For CR76, we only have a one note. This one we only have a property number PG4. There's no property number PG36. Okay, so only this a 56 and okay, only this a CR56 have a PG4 and a PG36. Okay, so only a CR56. So CR62 only have one. No, I think it's here. Why? Why did he say CR66 Okay, this one is not in the list. Okay, so based on the division of this client and the property number, the result is only CR56. Okay, so this one is using a division. So the main point here is that the criteria is not only one, but actually can be more than one. Okay, can be more than one. The table here need to fulfill all the criteria. Then only it will show the result CR56. Okay, so it need to match all the records here, PG property number. Then only it will show the client number in the result part. Okay. Okay, so students, we will end here. Any other questions? No. But for this time, my question only one, two. Casey, you also haven't mentioned whether you want to F2F or okay, only for this week online. Okay, Casey online. 28 face to face. Something face to face. Only 3. Young don't know. Others don't know. Okay, only 3 students reply. So others haven't decided yet. Okay. Why you haven't decided? So you haven't come back to Kampa, right?